We are continuing on with chapter 4. We're going on to sections 5 and 6, where we are going to be finding the determinant of a matrix and the inverse of a matrix. And we're going to be dealing with 2 by 2 matrices. Every matrix has a real number, which is called the determinant of the matrix. And this is the formula for finding the determinant. So this is my starting matrix with A, B, C, D as my elements. And then this is the formula. You multiply on the diagonals and always subtract. So AD minus BC. We're going to apply that to some examples here. Okay, the first one, our matrix is 1, -3, 4, -2, and it says find the determinant. So I'm just going to write out all my work here. So it's 1 times -2 minus 4 times -3. Usually if there's a negative sign with a number, I usually put that number second so that I can put it in parentheses. That's just how I organize my work. Okay, so now we're going to go ahead and solve. 1 times -2 is -2. And I'm going to go ahead and take this negative sign with the 4. So -4 times -3 is +12. And then combine those like terms. -2 plus 12 is 10. So the determinant of the first matrix is 10. Okay, the second matrix, -4, 6, 2, 3. So again, multiply on the diagonals. -4 times 3 minus 6 times 2. And then go ahead and simplify. -4 times 3 is -12. -6 times 2 is -12. And combine like terms would be -24. So that is finding the determinant of a matrix. Now we're going to apply our knowledge of finding a determinant to find the inverse. So the multiplicative inverse of a matrix A is A to the negative first. That's just the notation. So if we're starting with this matrix here, A equals A, B, C, D, then the inverse can be found like this. So it's going to be 1 over the determinant. So that would be the number that we just learned how to solve in the last slide. And then we need to switch some things around. So D and A switch spots, and then B and C switch signs. So D and A switch spots, B and C switch signs. So when we go through the examples, the first thing we have to do is find the determinant, and then we can bring the determinant down underneath of 1, switch things around inside the matrix, and then we go ahead and multiply it out. So this would be D over the determinant, negative B over the determinant, negative C over the determinant, and A over the determinant. Obviously, the goal is to have smallest terms and things like that, so if they can be reduced, then we would reduce them. This will make more sense in the next slide when we do examples. Okay, so we're given the matrix A equals -1, -2, 3, 4. We need to find the inverse of that matrix. So the first thing we need to do is find the determinant. So that's where we multiply the diagonals. So -1 times 4 minus 3 times -2. -1 times 4 is -4. -3 times -2 is +6. And then -4 plus 6 is 2. So now I need to find the inverse. So I'm going to take 2 and put it underneath of 1. And then I need to move some stuff around inside matrix A. So 4 and -1 switch spots. And -2 becomes positive, and 3 becomes negative. And now I need to multiply it out. So I've got 4 over 2, 2 over 2, -3 over 2, and -1 over 2. And then I need to go through and reduce. So 4 over 2 becomes 2, 2 over 2 becomes 1, -3 over 2 is going to stay, and so is negative 1 over 2. I would much rather see fractions here instead of decimals. So that final matrix that I just circled is the inverse of the starting matrix A. All right, last example. I have matrix 3, negative 1, 5, 2. I need to find the inverse of this matrix, so I'm going to start by finding the determinant. So 3 times 2 minus 5 times negative 1. 3 times 2 is 6. Negative 5 times negative 1 is positive 5. 6 plus 5 is 11. And now I need to find the inverse, so I need to put 11 underneath of 1. And then I need to switch some stuff around in matrix A. So 2 and 3 switch spots. Negative 1 becomes positive, and 5 becomes negative. And then I need to multiply. So I'm going to get 2 over 11, 1 over 11, negative 5 over 11, and 3 over 11. So looking at those fractions there, I know that none of those numbers can be divided by 11, so that would be my final matrix. Okay, and your homework assignments will be on Google Classroom.